And we're back. Back here at the Land Tamer stream. I went to go relax and do some research on the lab I just did. I couldn't let it go. Just couldn't let it go. Something has bothered me really bad. And it has to do with IGMP and what in the heck was going on with the IGMP message from router 6 reaching router 5. That, more than anything else, has bothered me. Plus the fact that on Discord I've been chatting with some others about issues that we've been sort of seeing in with multicast labs and some of these virtual environments. So I guess I kind of have something that I want to just prove to myself or disprove, I guess. And the problem packet in question is, if you saw the last lab, you know what I'm talking about and on the screen, is these IGMP membership reports for group 239.6.6.6. All right, this is on router 5 on this interface. Well, yeah, GI01, which has sub interfaces, right? That's how these labs work in viral. We have these sub interfaces, and anyway, you know what I'm talking about. So maybe it has something to do with that. That's the only thing I could think of. So what I want to do is I want to sort of do the same lab, but I'm going to create a different topology, right? So I'm waiting for viral starting up now. And what I want to see is the behavior of this IGMP membership report packet. Just for my own sanity. I don't feel like I can go any farther until we understand how that works. And, rule out whether it's true or not that we have some sort of bug. Or that it's some sort of limitation of the software, right? So I'm going to open up the via Maestro this time. And I may munch on some things here in the interim just because I grabbed a snack. I was going to sit down and eat. I'm like, no, I can't. I just can't let it go. Now, in the lab, in the real lab, this would be different. I would have let these points go a long time ago, right? But we're in learning mode here, so we have to learn. And what I'm going to do, I think this simulation, no simulation is going to run automatically, so that's good. I'm going to copy this and paste. And we're going to call it multicast testing. And we're going to, we might leave that switch, but I think what I want to do is, we're in design mode, right? Yeah, go in design mode. Let's delete this interface and put router 5 here. Delete that interface. Router 6, router 5, and we're going to go router 8. Well, wait a second. I need router 1, don't I? Yeah. Router 6, router 1, router 5, router 8, and router 10. Yeah, let's do that. And we're going to make this real simple. We're just going to have single links. Cool. Awesome. So these we're going to just delete. Okay. Or 615.810. Good. All right, so this is our new path. And let's kick it off. Let's close that. Cancel. Shoot, did I modify the wrong thing? I hate when I do this. I hate when I do that. Let's do a close. And no, do not save changes. Okay, this is the one I want to edit. You got to really watch that environment, man. All right, so router 6, 1, 5, 8, 10. And connect these bad boys point to point. Okay, and then we're going to save and launch this. Yes. All right, so let's see what happens here, guys. Let's open our requirements that we had before. If you weren't here for the last stream, this is basically, I did a PIM assert lab. And we had all sorts of instabilities and issues. Like, at one point, the lab was doing what it was supposed to. First of all, the lab itself was flawed in the premise of how routing would happen. It did not work the way, even copying the config directly from the workbook. So it did not behave as expected, and the routing did not behave as expected, and took multicast off of some interfaces, turned it back on, and then the multicast routing started working again. So it was very unpredictable, and I saw some packets that I saw a packet that just kind of rocked my world. It's like, whoa, what is going on here? I saw a router from router 6 coming into a router. It should not be seeing it, and it was captured on the interface. So I thought, okay, I just need to make a simple topology here and configure multicast. And, we're going to do multicast dense. So we're going to do multicast dense mode. And we're going to create a IGMP join request from router 6, 239.666, just like we had before. We'd have to change these interfaces up, so it shouldn't be too bad though. Like router 6, let's just go ahead and do this. Interface jazz 01, no shut, IP address 155.1.146.6 and IP PIM dense mode. And then we're going to have an interface. Well, we'll leave it at that for now. We'll come back. We'll come back to that. We're going to have to redo our interfaces here because we're doing our own. Actually, this will be, GS01. And then router 1, GS01 will be IP address 151.6.1. No shut. IP PIM dense mode. We're going to do 2. I don't know how these routers are going to come up. Let's see what they look like. They won't be scratch, I don't think. Show run. Yeah, router's still booting up. And I got an egg roll over here. Okay, so yeah, we need to clean those up. And we need to say, let's see, show. Remove all this banner stuff. I got a feeling we're going to be using this lab for, it's taking a little time to do this. It's a bit of a distraction. But I have a feeling that we're going to need it for some other labs. Judging on how what other people told me about issues they've had in multicast labs and virtual environments. I mean, if we have to do these on INE rack rentals, then we'll do that as well. But hope not to have to use any tokens yet on that. So we need to just clear the interfaces. Looks like they're running RIP by default. Oh, no interface. Yeah, we'll just do no interface T0. Loopback we'll leave in place. Okay, that's all I care about for right now. All right, and then interface Jazz01 and show IP. Yeah, I think what we have is this is Jazz01. Yeah, Jazz02, Jazz01. Okay. So 2 is facing the other side, right? All right. So on router 1, we're going to have this. Default interface, yeah, interface, no interface 2.0. And this will be Jazz01, right, yep. And then interface Jazz02, no shut, IP address 155.1 dot, let's see, it was 169.254.1.1. Okay. Then we'll go to router 5. And router 5 will be, oh, where's my chat? Let's get my chat window up, just in case. Chat's usually light, small channel right now. But just in case anybody wants to hang out and say hello or give feedback or say, hey, idiot, why did you put that interface in that mode? That's great, go for it. I appreciate any and all feedback. Now this needs to say, we're gonna go ahead and turn on IP PIM dense mode. And the same here, router 5. And now Jazz01 is going to be towards router 1. So it's going to be 169.254.1.5. And Jazz02 is going to be towards router 8. Yeah. So it's going to be 151.58.5. Okay, then we can go on to router 8. Oh, I need to put IP PIM dense mode. And router 8. As we go along, folks, we're going to be doing a lot more. We will be doing a lot more of our own labs as time goes along. So better get used to it now. Interface Jazz01 is going to be 151.58.8. And this will be towards router 10, so this is going to be 108.8. And then we just have to do router 10. I will clean up the IGP as well. We may just do EIGRP for the purpose of this lab. That's one thing I've not used in is this AutoNet kit. You know, you can in AutoNet kit you can automatically deploy, you know, like EIGRP and things like that. But anyway, router 10. Okay, we're gonna do here 108.10. Yeah, and then we won't need. Okay, let's see how this rolls. Router 6, we start on this end. Router 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So telnet 1, 2, 3, 4, 5, 6. Yeah. Yeah, we have to see what addresses we're using here. which is usually easier to do in the browser version. See what ports we're listening on, and to do captures and everything else is just easier to do here. So my simulations go away. It says false, reachable. Not sure about that. It should be fine. 17006. Telnet viral 106. Okay. Pop that in there. Interface GI02. There is no GI02, I take it. Good. Why you changed it down? Okay, you changed it up now. Okay. Oh, what we should do here is interface GI00 shut. Yeah. Wait, that's router 6, right? Yeah. Overlaps with GI0146. Oh, did it not take show IP internet? When I did a default interface GI01. Okay, shoot. So I got to take these out individually. Default interface GI00. There is no 02. We're gonna shut that down. GI01 is no shut. And actually what we'll do on here is say no interface GI01 146 0167. Okay. Yeah, let's try that. Perfect. And router 1, so we need to make some changes here. And we need to say no interface GI01 146, no interface GI01 13. I think that is it. Oh, 100, right. And then no interface GI01 100. Okay. All right, so let's put this on router 2, or 1, I should say. Default GI02. Oh, we need to do this here, don't we? He will have 2 interfaces. Perfect. Nice. Okay. Now let's go to router 5, and he will have 2. No interface GI01 100, no interface GI01 45, no interface GI01 58, no interface GI015. Okay. Router 5, you are 17004. Hey, we have a DR change. Good. Nice. Okay. Not too bad. Going to router 8. We want to do no interface GI0158, no interface GI01108. No interface GI018. I think that is it. Okay, and router 8, what are you listening on? 17008. Awesome. And router 10. we'll have no interface GI0110 and no interface GI01108. Okay, good. And you are listening on port 2. All right, so let's just look at our interfaces. Show IP interface brief. Good. Now this is down. 01 is down. Why is that? Oh, there it goes. Show IP interface brief. And it's up. Okay. And let's do... What are we doing for routing here? Router OSPF1. No router OSPF1. Router IGMP 100. Network 0000. Let's do that on all the routers here. No router OSPF1. Router IGMP 100. 0000. And same on, who's this, router 6? Duplicate IP address. Where is that coming from? You have a typo? Oh, oops. All right, let me fix it. Interface GI01, IP address. Okay. Going back here, router 6, no router OSPF1, router IGRP 100. And router 5, no router OSPF1, router IGRP 100, network 0000. And router 1 finally. No router OSPF1. Router IGRP 100. Okay. So now we should have learned about all of our neighbors, all of the IPs running, all the subnets that are in our environment, our LAN. We should have connectivity. Let's just see, show, let's see, on the edge is 6. Show IP route. Yeah, so we've got our loopbacks 156.8.10. And we have our Ethernet segments, so we should be good to go. I should be able to ping .1.10.10, and I can. Good. All right. So that part is done. Un momento. So what I'm going to do here is basically emulate what we did in the last lab to an extent. And we're playing Ghostbusters here because to me, that IGMP membership report message from router 6 is like an evil ghost, evil spirit that we have to root out in our labs. We can't have, if indeed it is illegitimate, which I think it is. So what I'm going to do over here is I'm going to tell router 6 to do a join. And then, we're all running in dense mode, right? If I do show IP PIM neighbor, yeah, we're all in, see, it says SPG, so we are status G, version 2. All right, so we should have, over in router 10, show IP in route. Not enabled, eh? All right, let's just make sure our environment is set here. Show run interface GI01. IP PIM dense mode. Oh, IP multicast routing. Oh, man. All right. IP multicast routing. It's like that. You remember when IP routing, you know, when you're on like a catalyst switch and you forget the type IP routing? What a pain, right? Okay. IP multicast routing. Interesting that we formed PIM neighbors, right? But we're not receiving any routes. So that's something we learned. T multicast routing and IP multicast routing. Show IP and routes. So we should see some basics here for the all routers. DCL dense mode connected local. Good. Okay. Now we are ready to get, we're going to do a capture here. We're going to do first on router 6. We will do an IGMP join. And this is where IP IGMP join group, and it's going to be 239.666. So I want to see where our star comma G goes. How far does our star comma G go? My theory is it gets multicast and sent out, and R10 should have a star comma G en route, and it should have received an IGMP report from router 8, right? That's what I expect to happen. And if that's the case, then we were right in doing our own lab here, right? So IP IGMP join group 239.666. We're going to do a capture on router 1 and router 10. Okay. And we're going to do it on GI01. Let's see. Do we want to do it incoming and outgoing? No. All we need. Yeah, let's do it. Let's do it. Why not? GI02 and GI01. Traffic capture. We're going to do IGMP PIM. And captured group name is going to be R1, R10. And we're going to do IGMP or PIM or ICMP. Okay. All right, let's get to cracking here. Boom. And let's see what we see here. Show. Okay, it does not, so far, it has not reached router 10. He does not have. So maybe it only goes. Router, where did I put that? Router 1? No, I should have put it on router 6. Show IP en route. Okay, there it is. Neighbors directly connected. All right, now this is what we saw. This is what we saw in the lab before with the sub interfaces. Now I know it is sent with a TTL of 1. But does that mean that this is not broadcast out or multicast out to the other? It says OIL, so these are added as OILs. Does it send an announcement down the line? That's the question. Next to router 1 would be router 5. And I'm losing track here, router 5, right? Okay, so that's as far as it goes. It just goes to its neighbor. Okay, good to know. That would explain why. I guess that could explain why router 5 would see it, but of course would not, would just drop the packet. Okay, that's starting to make a little more sense. So when I do a ping, when I do a ping for this group, how does it know to get there? Let's look at our captures thus far. I think I know what I'm going to see, though. I guess that's the difference, right? That's dense mode. It's just going to send it everywhere. So let's look at router 1. Interface GI01. We already know what we're going to see there, I think. We're going to see an IGMP membership report. And we do. We see it with a certain interval, right? Membership report, membership report, membership report. But we won't see it going out interface 2. Right, okay. Now this one we do, that's an exception, right? That's 224.01.40. That's kind of built in, right? Okay, all right. So then I guess the key is for router 10, when he does a ping of 239.666, yeah, it's going to reach because now we should have a S comma G, which we do. Flag T, okay. That's router 1. If we look at router 6, or router 8, interesting. So star comma G, incoming interface is null, neighbor, outgoing, stopped. Interesting. So what I've learned from doing this lab is that in dense mode, it's cool, we got a little packet captures there. In dense mode, when I send an IGMP message and announce that I am a receiver, it only goes to, it has a TTL of 1 and then stops. When I send as a sender, when I'm a sender to that group, it's just going to go everywhere. And then what will happen is, I guess because we get a reply, are these useless or not? This is router 8. He has an mroute, star 239.666. All right, let's compare this one to the one on router 1. Okay, this is stopped because it's the shortest path tree. But the incoming interface is a neighbor who sent an IGMP message. Outgoing GI01 and GI02, forward dense. If I do a continuous ping, these still say stopped. Why, when I'm sending packets, would it say stopped? We have T and DCL here. Uptime expires. Let's look at router 8. Okay, interface state timers is up here. Uptime expires. Interface state is the interface. Next hop or VCD, not sure what that means. And then state and mode. Outgoing interface flags. All right, let me stop the pings and see if so what is different here? I guess I still don't know what stopped is. Yeah, I'm confused by that. Yeah, P is prune, right? Now there's a timer here, where there was not one before. About a router 1. This always says stopped. Yeah, I have no idea how to interpret that. OIL, outgoing interface list. This is the interface. .0806 stopped. What in the heck does that mean? What does that even mean? Well, the purpose of we wanted to learn what the IGMP message did. Now we know. Now I'm trying to interpret this table. And I don't know what this means, stopped. These counters are going up too. This timer, I think when this gets to 3 minutes, it will expire. Oh, the timer's counting down. Right, 47. This timer is counting down. These timers are counting up. All right, I want to see this disappear. 30 seconds. The S, G should disappear. And then this must be the neighbor time? interface state, interface comma, next hop or VCD, RD and vector. Oh, okay. Connected dense. And then the timer is state / mode. Okay, yeah, that one just flushed. So I guess it's whenever the... Yeah, 1234 and 1036. So what if we do that? Yeah, this is for 2240140. What would be here other than stopped? Oh, let's see. Interface GS02. No PIM. No IP PIM dense. It immediately just disappears. So PIM dense. All right, so what I'm curious about is what will happen with dense mode. The same scenario. We're going to stop the lab. I want to download this. Which I think it did, but I have no acknowledgement that that even downloaded. Let's do kind. Okay, it downloaded. So let me... I'm going to delete this. And we're going to stop the simulation. And we're going to actually go over here to design mode. Wait for it to stop. And we're going to create another branch. Maybe at, let's simulate at router 5, just like it was in the other lab. And this was my theory, is that IGMP propagated throughout but it obviously does not. So let's select another router. Let's copy this one. Oh, we didn't save our configs, did we? That's okay. Yeah, let's have another route here. And it's going to basically be a dead end, right? So we're going to have, let's call this R4. And we'll call this, doesn't matter, R7. And let's connect these bad boys. We'll connect him to here and him to here. And we'll fire it up. Cancel. Save. All right, let's see what happens. All right, so I'm gonna have to come back here to these, and we'll basically do. So now we got router 4. And for him, we're going to do, I don't know what he's got going on here. But interface GI0 kind of launch. Do you want? Yes. So GI01 and GI03. Okay. So we need to come up to router 5. And interface GI03. No shut. IP address 151.45.5. IP PIM dense mode. And want to do our routing stuff here too, right? No router OSPF1, router EIGRP 100, network. Okay, we need to put this on all the routers as well, just in case. Router 6, router 1, router 5, router 8, router 10, and of course router 4. And let's see, no banner. Okay, so GI03, GI01 is going to be 45.4. And then what is this interface here? This one is, okay, 1 going towards 2. That's interesting. Oh, 2 that way. Yeah, GI02, GI01. Okay. So this will be, we'll call it 47.4. And on router 7, we are going to say just GI01. .7. Okay. I think I have this twice. Yeah, GI0, 1 and 2. Is that right? GI01 is towards router 5. GI02 is towards router 7. Yeah. Yep. Okay. And okay, just checking on my different things over here, guys. All right, so that is booting up. Let's see. It may take a minute for the routers to come up here. Router 1, okay, he's ready to go, looks like. This may take a minute. I'm watching my frames here because so far so good. We've had no drop frames on the network, which is good. All in all, I've been monitoring since I put up this monitor on the stats on the stream health. It has looked really good. I haven't really had any major issues here. I rarely get above 0.1% of frames missed due to rendering lag. So that's good. I've been happy about that. Show IP interface brief. Let's just take a look, make sure. Okay. It looks like it saved the configs before it. Okay, we should have router 6 first. That's okay. Router 6. Oh yeah, he's back to defaults, I think. Oh, this says router 5. Okay, I'm a little confused here. Let's go to our simulation. See who's who. Okay, router 5 is 170.6. Okay, which is that one. 1, 2, 3, 4, 5. Okay, yeah. And then router 6 should be 170.8. We'll get it. Okay. And so that's router 6, then that's router 1, and let's go to router 5. Yeah, I know, CPU hog. And we'll go to router 8. And he is on 12. No, not. No. 2, 3, 4, 5, 6, 7, 8. There we go. And router 10 should be on 170.2. We're doing on frames. Nightbot here? Are you here, Nightbot? Oh, FPS. There we go. That's router 10. Then we'll go to router 4, the new guy. I hope we don't have a lot to configure here. We might have to do host name or something like that. Let's see. Router 4 is 170.4. Okay. Okay, interesting. He came up with a personality crisis here. We're going to change his host name. Host name R4. Okay. Duplicate IP address. Oh, I remember. Show run interface chat 01146. Yeah. Interface chat 01 IP address. Let's change it in the script so we don't forget that. Okay, and we just did router 4. Now on to router 7. He may have an identity crisis as well. Oh, because we did a copy. That's right. That's right. 6, 7. Yeah. Host name R7. We probably have some sub interfaces on here also. Let's look at those. Router 4. Show IP debris. Yeah. No interface jet 0167. Interface jet 01046. And same with router 7. Okay. Good. Show IP route. So we got router 1, router 5, 6, 8, 10, loopback. is probably wrong. Yeah. Same with router 4. Okay. All right. So show IP route EIGRP. Still do not see 7 yet. Yeah, 151 cent. Oh, deleted. Okay, that's right. Ping 151.47.4. Yes. Okay, we still don't have 4. Let's do a shut, no shut. And same on 7. Show IP route. Yeah, JRP. We're not running EIGRP over here? We are. Well, obviously we are. Look at these routes. Okay, why don't I have router 7's loopback? Show IP route 150.1.7.7. Oh, RIP. Ah. Route metric is 1. Distance is 120 though. Yeah, man, I'm still not learning it. Do we have to redistribute? Redistribute connected. Still not getting it. Okay. At least we're not learning it through RIP. And he is not advertising his. All right, it's probably just a order thing. Let's do no router EIGRP 100. Network 0000. Routers don't always work the way you expect them to, man, I tell you. There it is, yeah. We'll do no router EIGRP 100, router EIGRP 100, network 0000. Okay. There we go. Okay, so we have our basic lab up. And what I want to test and figure out, anyway, how this works is with dense mode. If I set up 6 as a IGMP group member, and I send a ping from router 10, hold on, folks, I have a call. I have Okay, yeah, guys, so there's something I gotta attend to, work related, but I'm gonna do this real quick. We're going to see, does multicast traffic, when it leaves 5, does it go down both interfaces? Because we've advertised that we have a receiver this way. Router 10 does not know. So, yeah, so what exactly happens here? You know, does traffic go both ways? We'll see. Or does it go both ways and then we get a message back saying, prune, there's no receiver? I don't know. I don't know exactly how that works, so we're gonna find out. So let's see here. Let's do. We've got everything lined up, so I'm gonna do a capture here. We're gonna capture on router 5. And we're gonna capture on both. Let's see, this will be 01 and 03. 01 and 03. And we're going to do traffic capture, and we're going to capture IGMP. And I think I have to do a group name, R5, both directions. And we're going to say PCAP filter is PIM or ICMP or IGMP. Okay, so let's see what happens. I mean, to me, the whole purpose of an IGMP message is to let people know that they can send traffic this way, right? Otherwise, why flood? Well, no, because that's the purpose of sparse mode, right? So does this not really do anything, this IGMP join? Is this basically a worthless message in dense mode? Maybe it is. I thought I understood dense mode, but obviously I don't. So we're going to now ping. Well, we have to do join over here, right? On router 6. Yeah. Show run interface GI 01. Is it 01? Yes, it is. GI 01, and we're going to say IP IGMP join group. And what is it? 239.6.6.6. Okay, so the only router 5, even after this, router 5 is not going to know about star comma G. Show IP mroute. Oh shoot. Guys, it would help if I do IP multicast routing. Why did it close my connection? Oh, is that? Oh, that was formerly my router 10. That's fine. Man, I cannot forget that. Okay, ping 239.239.666. And we do get a reply. So now let's look on show IP mroute. Yes. Okay, forward dense stopped, and this is not stopped. Prune. How does it know to prune this? So what must happen is it goes this way, and router 7 says it replies to 2, 3. Okay, so it replies to this address, the sender. Or maybe it just sends a prune message because it's saying, what router 1 would send one too. Okay, I definitely want to see what happens on this capture. I don't know what that means. Simulation not found. My simulations. Okay, I must have hit something, backspace or something. Reachability changed. Where's my capture? There it is. People are weirding me out here. All right, so let's look at R5 both directions. And first, let's look at this one. Okay, he's just sending the pings here. He's sending out the OIL interfaces, right? So the source is 10, the destination 239.666, and router 5 should actually be sending a reply. Yeah, he never gets any membership report groups for this. What does it look like on the other interface? Okay, we have a join prune here. Prune, who sent this? Router 4. So I guess what happened is, let's capture. So traffic is controlled with the prunes, not with the joins. That appears to be, to me, to be what is going on. Let's watch router 7, what he does. I think that's the key. Or we should say router 4. Yeah, let's capture router 4. R4 to R5, let's capture both. Why the heck not? So this is R4 both, and we're gonna do IGMP. Yep, all the same. Okay, so right now, if we look on router 4, D, so he has, okay, so this must be the result of a prune message. Is that why he has this DCL? Incoming interface null. In other words, I have no receiver. Res router 1, show IP mroute. Incoming interface null. RPs are 0. Yeah, we don't care about RP. DC. These look exactly the same, as if they both have receivers. Okay, anyway, let's go to, let's do some more pings. And now in router 1, we have S comma G, and RPF neighborhood is T status. And here, we know about this, but it's pruned. And how about our router 7? It is pruned. Okay. So RPF check is correct, but he has no outgoing interface. So when he receives a packet destined for this group, he has no outgoing interface, so he must be the one sending a prune. Router 4 has an outgoing interface. So essentially what happens is this hits a dead end. Router 7 is, hey, I have nowhere to forward this. It came in this interface, but I have no interface to send it out. So he sends a prune, and he sends a prune. Prune this interface, router 4. Router 4 sends a prune this interface. And if we look on router 5, show IP mroute. Forward dense, and this is prune dense, right? Okay. Good. I think I understand. I think I got it. This really helped. Yeah, this really helped. Let's look at those packet captures, then we'll probably wrap it up there because I've got a work-related call I gotta make now. Let's look at router 4. And we should see an incoming prune and an outgoing prune. Find the prunes, guys. Prunes are healthy. Prunes are good for you. You can never eat enough prunes. Makes you regular. Look at this interface. And let's see, membership. There's a join prune right here. And it says, hey, this group right here, you need to prune that. Now the source, this is from router 4. Now what interface is this? Jazzer 1. Okay, that makes sense. The other interface should be from router 7 to 2240013. Yeah, there are no receivers, right? So in dense mode, it's just a matter of send it to the all routers address, 2240013. Okay. I think I got it finally. I think we're good to go. I may go back and do that PIM assert. It may not be tonight, folks. I've been labbing for a long time today, and I've got to make a work call, so this is probably going to wrap me up for the night. I do want to say, though, thank you very much, everyone who's watching this on YouTube or who tuned in to the stream on Twitch. Check us out on Twitch, and we've got Discord, Instagram, Twitter, Facebook, you name it, we're there. And looking forward to meeting up with other students, other people wanting to learn, and other people who are wanting to collaborate on projects, study projects for CCIE routing and switching. So thanks again for tuning in, guys. It's been a great day. We shall see you soon back here in the Land Timber stream. Hope you get all the good bits in your labs and in your study. Take care.